Okay, so we're going to go back to the class exercises and we're going to look at how to solve these. And we're solving by finding each logarithm without a calculator. Now I want you to notice that in all of these, the directions on the paper for page 194 are all the same. The directions say find each logarithm, but there's no equal to. So what I would like to do is I would like to set it equal to x. We don't know what that is, but we need to have that in there because that's part of our format. So each one of these needs to be equal to x, as x is what we're finding. We're finding the log. And Miss Meek eloquently explained last lesson that the log is the exponent. That's what it is. So, and if you notice, the equal to this position is the exponent position. So as we go to rewrite this into exponential form, because we find or we solve these using exponential form, that we are going to start with our base, which is our subscript 7, raised to the x power equals our answer, and our answer is 49. So if I'm going to solve this for x without a calculator, I know that 7 squared is 49, so x equals 2. Okay, remember, the log is the exponent. That is what we're solving for. In letter B, we would rewrite this in exponential form to say the base 2 to the unknown power x is equal to 16. So now we have to figure out what power of 2 gives us 16. Well, 2 squared is 4, 2 to the 3 is 8, 2 to the 4th power is 16. Okay. Next one, up another base of 2, exponent we're trying to find, except our answer here is 1/8. Now this is a little different. Keep in mind that when you're going from a base of 2 to a fraction, that means that we need to change this fraction into a common base of 2. So I'm going to rewrite this again, but I'm going to use 2 as a base. So this is 1 over 2 to the 3rd. 2 to the 3rd is 8. So we want to get them with a common base so that we can see. And we want this fraction written as 2 to the whatever power. And remember, when there's an exponent of 3 in the denominator, that means that there's going to be 2 to the negative 3 in the numerator. So that means that our x value has to be negative 3. That's what's going to generate our fraction. Look here, we have another fraction. So, except this time we have a base of 5. So 5 to the exponent is going to give us 1/5. These are already common bases, but this is really 5 to the 1st, which goes in the denominator. So that's 5 to the negative 1 as an exponent in the numerator. So x has to be negative 1. And this one is a radical, so that's interesting as well. And again, looking at it from an exponent point of view, the base is 5, the exponent is x, and that's going to be equal to the square root of 5. But we need this as a common base, which the 5 is a common base, but we need to rewrite this as 5 to a power. Now remember, this is square root. So remember, square root and 5 to the 1st. This is 5 to the 1/2 power. Remember that square roots and exponents are interchangeable. And this would be 5 to the x equals 5 to the 1/2. So x has to equal 1/2. So all of our exponent rules that we worked on previously are coming back. Our negative exponent rules and our radicals are coming back to us in logarithmic form. Now what we're going to do is we're going to work on number 8 and number 9. Same class exercises. I rewrote them already. Let's see what we can do with them. Again, solving no calculator. We're getting this into exponential form so we can solve. the base comes first. The base is our subscript 5. Our exponent is 2. And that equals x, our answer. So they're looking for us to solve for x. So 5 squared, oh yeah, x is 25. Here, 6 is our base. Exponent is 2, equals the answer. 6 squared is 36. This one's a little bit different because the log doesn't have a base. So remember, if there's no base written, the log has a base of 10 as it's understood. So our base is 10. Our exponent is 2. So this is 10 squared equals our answer. So our answer must be 100. And this one, with the natural log, our base of a natural log is always e. So this is e squared equals x, and we're not using a calculator, so it would just be e squared. Done. Let's move on to number 9. Again, just looking at these, we're putting them into exponential form so we can solve for x. The base is now x, so we start with the base to the exponent equals 121. And of course, in order to solve for this, we would have to take the square root of both sides. In this case, we've got x as our base. Exponent is 3, 64. Cubed root, taking the cubed root of both sides. The cubed root of 64 is 4. This is x to the to the negative 1 equals 1/2. So a negative indicates that we are going to have something downstairs. Well, what's downstairs? That would be 2. So if we rewrote this as x to the negative 1 equals, this is 2 to the negative 1, we would know x is 2. Okay, so it's just another way of seeing it, that these are the same, so these bases have to be the same. And the last one, x is the base, raised to the 1/2 power equals square root of 6. I could rewrite it as x to the 1/2 equals 6 to the 1/2. Remember that square root is really to the first power, square root, power root. So these halves are the same, so x has to be 6. All right, these are your model problems and examples. Please make sure that you have them all written down, and get ready for the next slide.